All right, so question number 10, system of three equations. I'm going to start out by using one of the three equations to eliminate another variable. The way you want to pick is you want to pick a variable that is isolated. So like x right here, it doesn't have a number in front of it. So I can easily manipulate and multiply this x to match one of the other numbers and then eliminate the variable x. I will eliminate x in equation 1 and 3, and that will leave me with two new equations with just two variables. I'll have y and z, and from there I will solve it just like a system of two equations and go from there. So I already worked one similar to this, so I know that this one will have a dependent system, and I'll show you how to handle that as well. So I'm going to write down number 1, and this is going to be equation 1. So this is negative 3x plus 2y plus 2z equals negative 4. Now, as I was looking ahead, I told you I wanted to eliminate x because it was by itself. So what I'm going to do is I'm going to manipulate equation 2. I'm going to take equation 2, and since I want to get rid of the x term, I need a positive 3x because they need to be opposite signs. So I'm going to take equation 2, and x is 1, so I'm going to need to multiply x by 3. Okay, so I'm going to multiply equation 2 by 3, and I'm going to write that result here. So I'm taking equation 2, I'm multiplying it by 3. So right now it's just x, so 3 times x would give me 3x. 3 times 6 would give me a positive 18y. And then 3 times a negative 5 is going to give me a negative 15z. And then equal negative, I'm sorry, not a negative 3. 3 times 17 will give me 51. Okay. So since I manipulated 2, that is not the new equation. My new equation, when I add these, is going to give me a new equation 1. That's the one that I left the same. I'm just adding another equation to it. So this is going to be my new equation 1. Add this up, x gets eliminated. Add this up, that gives me 20y. Combine these, I would have to subtract opposite signs, so a negative 13z equals, subtract here, and that will give me positive 47. Right here, 47. Okay, so this is my new equation 1. It only has two variables. That was my goal. Okay, so now I'm going to start with equation 3. I'm going to write it down. 4x plus 4y minus 7z equals 21. Okay, now I'm going to manipulate equation 2 again. I'm going to multiply equation 2 this time by a negative 4 because I'm going to cancel out the x. So 2, I'm going to multiply by a negative 4. Negative 4 times that equation. So negative 4 times x is going to give me a negative 4x. Negative 4 times the 6y will give me a negative 24y. And then negative 4 times 5 will give me a positive 20z. And then finally, negative 4 times 17 will give me a negative 58. All right, so I'm going to add these up. Now, since again, I'm manipulating equation 2, that's the one that has changed, so that's not the one I'm using. I'm using equation 3, so this is going to be my new equation 3. Okay, so I add these up. 4x gets eliminated. Combine here, I get a negative 20y. Combine here, and we get a positive 13z. And then when we combine here, that is that 21. No, 4. This should be 68. Okay, like something is not looking right. This is a 68. 4 times negative 17, 68. Okay, so when I subtract here, that gives me a negative 47. I wrote it in blue, should have been black, it don't matter. Okay, so this is my new equation 3. This is my equation 1. I now have two systems with two variables. I will line those up. So this is my new equation 1. I'm going to bring that down. 20y minus 13z equals 47. So now I want to eliminate either x or y. Now look, y's are already opposite, but you also notice that the z's are opposite. So everything is going to cancel out when you add this up. Negative 20y, positive 20y, we get 0. 13z, negative 13z gives us 0. Negative 47, 47 gives us 0. So anytime everything cancels out, you get a true statement. That means it's a dependent solution. And we're going to need to solve for one of these variables and write all the other variables in terms of that variable. And what we will do is use one of these two. So we've already eliminated x. So let's just say we're going to take this equation, and it doesn't matter which one you use, but I'm going to solve for y. So I want to get y by itself. So I'm going to take this equation, 20y minus 13z equals 47. I'm going to divide, well, I'm going to add the 13z over first. So that's going to give us 20y. That's going to get eliminated, equals 13z plus 47. All right, and then lastly, I'm going to divide by 20 to get y by itself. Okay, so 20 divided by 20 is 1, so we get this. Y is equal to 13 over 20z plus 47 over 20, and we're going to leave it just like this. So I'm going to need ordered, I say ordered pair, but it's 3 terms. I'm going to need an x, a y, and a z since I had 3 variables. I now have y in terms of z, so I'm going to need to do the same thing for x. I'm going to put that in terms of z, and then z will just be itself since I already have the other ones in terms of z. So I get to pick z, whatever number I want, and x and y are going to be in terms of z. So now I'm going to go back. I'm going to use equation 2 because it had x by itself. So x plus 6y minus 5z equals 17. Okay, so I'm going to get x by itself. I'm going to subtract 6. I'm going to add 5. I'm going to move those to the other side of the equal sign, and their sign changes basically. So that's going to give me x equals a negative 6y, sign changes, add plus 5z, and then the 17 was already over there, so plus 17. Now the z is already there, but y needs to go away. We already know what y is, so I'm going to manipulate and plug this expression in for y, and then manipulate this. So now we have x equals negative 6 times y. What was y? Well, y was 13 over 20 z plus 47 over 20, and then we have the plus 5z, and then plus 17. Okay. We can add these. It's going to take some manipulation. We got to distribute the negative 6 to both terms, and then we'll combine the z and the numbers. So I'm going to let the calculator do a lot of this work for us just to simplify or to speed up the process, and then I'll write each of those terms down. So I think I closed my calculator up. negative 6 times 13. So we're going to have 78z over 20 right here. Negative 78 over 20. That can reduce, but we'll leave it. And I'm going to go ahead and put the plus 5z next to it because those two things are going to get added together. Again, I'm going to let the calculator handle that for me. So like terms. Then I got to do negative 6 times 47. Gives me a negative 282. Let's say minus 282 over 20 plus 17. All right, so this gets quite messy with these three equations. Okay, so now that I have that done, I'm just going to let the calculator add the fraction. So I'm going to say negative 78 over 20. I'm going to change it to a fraction, alpha y equal enter. So if you want to get a fraction bar in the calculator, you can do alpha y equal enter. It'll put it in fraction form for you. Even if you don't do that, it'll still, you can convert it to a fraction, but this will do it automatically once I put it in fraction format. So I'm going to do negative 78 over 20. This is with the z, but I'm not putting the z in the calculator. I just know that it's with the z. Negative 78 over 20 plus 5. Okay. So it's going to do the math. It's going to simplify for me. So this gives me 11 over 10. So that tells me x is equal to 11 over 10z. That's this part. These two combine to be 11 over 10z. Now I'm going to do the same thing with the 282. So this time I'm not going to do it in fraction format, but I'm going to show you how to turn it into a fraction. So I'm going to do negative 282 divided by 20. Just going to do divided by 20. And then plus 17. Gives me 2.9. So if I want to turn that into a fraction, I can do math and then hit enter twice. Enter, enter. It's going to turn into a fraction, 29 over 10. So this is plus 29 over 10. So now I have both x and y in terms of z, and z is going to be itself. So you have to always do this. You have to turn one of those variables either in terms of x, y, or z. So this was a dependent system. X is going to be 11 divided by 10, division bar 11 over 10 z plus 29 over 10, and then y is going to be 13 over 20 z plus 47 division bar is 47 over 20, and then z is just itself, and z is an element of reals. So it's always going to be an element of the real numbers. That's what that symbol means. And you got to make sure both those terms are in terms of just one other variable, not two.